So here we have the design of our clutch assembly here. How this works is it transfers power from the engine to the transmission via contact friction. The general idea is these outer teeth fit into these slots here on the outer basket, which will be directly connected to the transmission via shaft. And the inner plates that are made out of cast iron have grooves cut into them. You can see that here, that connect to the inner basket, which is connected via shaft, spline shaft, to the engine. When these springs are bolted into the inner basket, they apply a force onto the clutch plates that makes a perfect no loss system going to the transmission and ultimately out through the wheels.
Okay, so here are the internal workings of our sequential transmission. The power will come in be through the clutch via the engine. These gears on the input shaft, also known as the lay shaft, are splined directly to the shaft. As you can see in the exploded view, this is a very expensive shaft to machine due to these machined gears onto the shaft in order to achieve high gear ratios with very limited geometrical constraints. Power will come in through the lay shaft. These gears will always be in mesh with the gears on the output shaft. This one is a 7-speed with 1 reverse gear. The dog gears will be spinning independently of the output shaft via needle roller bearings, which are riding on these dog collars. In order to engage in gear, the selector shaft, which is driven by an electronic module or manual shifter, will rotate clockwise. These shifter forks will move with the rotation of the selector shaft via this slotted path, which will cause motion forward and backwards, as well as motion in the dog ring, which rides on the dog collar, meshed directly to the output shaft, and engages the dog ring teeth with the dog teeth on the dog gears. That will cause the power flow to come in through the input shaft, through the gear, through the dog ring, through the dog collar, and to the output shaft. Both shafts are riding on these 4 cylindrical roller bearings. They are not tapered roller bearings due to the low axial loads in the shafts. And the second type of bearing in our system is the needle roller bearings, which are due to geometrical constraints due to the low profile between the dog gear and the output shaft and dog collar. There's our construction.